This is the first video where we're going to practice prime factoring a polynomial. And here are the steps for prime factoring. First, always make sure your polynomial has been written in standard form. Next, factor out any greatest common factor. After that, you choose the technique based on how many terms there are. For binomials, try the difference of two squares. For trinomials, guess and check is a good way to start, but if you've tried for about 20 or 30 seconds and don't seem to be guessing a good combination, then shift right into the AC method and get the trinomial factored, as long as it's composite. If you have 4 terms, the technique is factoring by grouping. Step 4 is the hardest for people to appreciate when they start factoring polynomials. That is, when you think you're done, you need to go through your factors one by one and make sure that they're prime. If they're composite, you need to return to step 2 with that factor and continue factoring until all your factors are prime. Keep in mind there's a difference between factorization and prime factorization. For instance, 2 times 6 is a factorization of 12, but only 2 times 2 times 3 is the prime factorization. In the same way, you might factor a polynomial and get a couple of binomials like this, but then you need to recognize that both these terms share a 3, and so this factor is composite and can be factored further. On the other hand, this factor is prime and can't be factored any further. So you don't have the prime factorization of the polynomial until you've factored out the GCF and have this as your factorization. In the same way, it'll be necessary for you to look at 2 factors like this and recognize this first factor can be factored further. It's the difference of 2 squares. Whereas this other factor cannot. This factor is already prime. So the prime factorization for this polynomial would look like this. One last point. I'm not going to spend much time on factoring by grouping or guess and check or AC method or difference of 2 squares. There have been previous videos with those techniques. Here's our first one. The polynomial is already in standard form. There's a greatest common factor of r. After factoring that out, I see I have a trinomial left, and it's a good candidate for guess and check. Both the operations will be the same, both negative in this case, and 6 and 5 will give me my factored form. I need to last look at all of my factors and see that they're prime, and so I do have the prime factorization for this trinomial. Here's another one. Step 1 is to write this in standard form. The next step is to recognize there is a GCF of -1, which I'll factor out. I have a trinomial. It looks like a good candidate for guess and check, so I need to mix my operations since c is negative. And I can see that 9 and 4 will work. Once again, I go through my factors and make sure that all of them are prime. Of course, on a test, for instance, it's also a very good idea to, in your mind or on paper, distribute to make sure the polynomials are equivalent. How about here? First, I'll write the binomial in standard form. Next, I'll factor out the GCF of -1. I recognize this as the difference of 2 squares, and that factors to c plus 6, c minus 6. Here's another. This polynomial is in standard form, and I see there isn't a GCF. Since it's 4 terms, I'm going to have to start with grouping. Next, I need to check my factors, and I notice this factor is still composite. It's the difference of two squares. X squared minus 3 squared can factor 2, x minus 3x plus 3, and I now have the prime factored form. How about here? This trinomial is in standard form. I'm going to first factor out the GCF of 2. Even though you could try guess and check, I'm probably going to shift right into AC, with the product AC being negative 12. I look for my pairs and find that 1 times negative 12 will work. So I return to the original and factor using the AC method. Last, this set of parentheses is no longer needed. And last, I convince myself that all these factors are prime, and so I have found the prime factorization. How about here? After writing in standard form and factoring out the GCF of y, I recognize this binomial as the difference of two squares. It's the quantity 3y squared minus 1 squared. That will factor 2, 3y minus 1, and 3y plus 1. Looking at all my factors, I can see they're prime, and so I'm finished. Well, that concludes this first video where we've begun prime factoring polynomials.